Hello. Hello. In this video, we will learn about generics mostly and a bit about traits. So let's see how we get started. So we have covered a lot of traits. Now suppose we have two different traits and they have the same method. That is method name get. It is quite common to have such a method name. Now, both may return same type or different type. For this example, does not matter. In general, it wouldn't matter when we look at the exam. And so you see, get returns a string for username and age widget returns a unsigned 8-bit integer. Now we have structure form which has two members, username and age, which are string and unsigned 8-bit integer respectively. Now suppose this form implements both the traits, that is the get method for both. So in one it returns the username, in another one it returns age. So we construct a form object, and if you uncomment this line, then it will give you error. The error is get found candidate number 1, candidate number 2. So it is asking you to disambiguate. Okay. So the way to disambiguate is to write the fully qualified name. Okay. So the fully qualified name would be form as username widget, and then we get the string, the username, and then you say form as age widget. Okay, that's how you disambiguate between two different traits, and then you can invoke get on the form. That is the object of the structure. Now the main thing about this video is the generics. So those who come from C++ or Java background or even Golang, they will know what generics is. Okay. If you have not studied those languages, then you wouldn't know about generics. So generics allows us to execute the same piece of code for different types. Okay. So in C++, for example, C++ templates are insanely powerful. We can even argue that C++ templates are far more powerful and complex than Rust, generics, and macros. Even if you combine macros and generics and Rust, it may not be as powerful as templates, but things are also under development. Plus, the goals or objectives of templates are completely different than that of Rust. So in Rust, generics implement using two things. One is that it substitutes for different values. That is one part of that. The second is the correctness comes from the traits. Okay, that the generic value, what it is trying to operate with, that matters. In C++, generally it is by substitution. The compiler substitutes the values with which you instantiate the generics. But in Rust, it also puts a restriction that what the value can do. For example, we take a simple example here. So suppose we have a function called print value. Now it receives a type t, a value of type t. Okay, and that value will obey the debug trait or will satisfy the debug trait. And then the argument to the function is that value t, and we print the value. So we can pass 10, we can pass hello, and it will be printed. We can pass even elements of a structure and it will be printed. Now suppose you want to do the same thing to a box. So box t has a member value t. Now we can invoke this by calling value colon 5, value colon Rust. Okay. So it will create two different int boxes. One, as you can see, a box of I32, another is box of string slice. Now once we have that, we can print those values. So you see that the traits is here, the trait is here. We'll see more example of this. So this is the simplest example I can think of. Okay, yeah, function takes an argument, does something with that argument. Simple stuff. More complicated stuff would be that, for example, this code, if you look at this generic, so this function computes largest. What it receives is it borrows a list of values. Okay, T is the generic type here. Now it borrows a list of values. Now what this list of values does is the trait which we require is partial order and copy. Okay, so for example, if you do this, then you can't get this element into largest. Okay, so copy trait is needed. And we need this greater than sign, so we need partial order. So there are 4 traits I would like to talk about. One is partial EQ or partial equal, another is odd, another is EQ. So partial odd and odd allow you to compare with greater than less than. Partial EQ allows you to test equality with double is equal to and not is equal to. And EQ is a more strict variation of the partial EQ. So here we copy the first element of the list and put it in the largest variable. And then we iterate on the list and we compare if item is greater than largest. If that is the case, then we assign item to largest. And finally, we return largest. So you see, return type of the function is also T. Okay. Once we have that, we can create a vector of numbers 37295, and we have a vector of characters A, Z, M. And then we can invoke largest on both the numbers and characters. So we send we borrow the numbers and characters in the largest function, and finally it will be printed. Oh, by the way, I have not been running the code, so I should show you by running the code. Let's run this. So what should it print? It won't print anything. There is assertion, so it will simply tell if assertion fails. Cargo does not exist. All right, that is weird. Okay. Okay. I remember I deleted one file from that. Okay, fine. So we go to videos, first programming, and this video first. Let me increase the font and we say cargo run, and it does not complain, so assertions passed. Now we need this gen1, cd gen1. So you see what should be printed in this case. Int box value will be 5, so 5 and rest will be printed in this case. Cargo run. 10 hello, 10 and hello from here, all right, and then 5 and rest, all right. I missed the first 2. So in this case, it will print the largest number, so it should print 9, and the largest character should be Z. Okay, so we go to gen2 and we run cargo. So it prints the largest number 9 and largest character Z. Now we come to something called mixing, or rather multiple generics. Okay, so we don't necessarily pass only one type. You can pass 2 different types. So this struct pair takes 2 generic arguments, T and U. It has a member first which is of type T and a member second which is of type U. Now we implement the pair for this structure. Okay, we implement this function mix. So mix also takes 2 arguments, generic arguments VW, and of course one will be the self argument, and the second would be it receives a pair of type VW, and notice it returns a pair of type T and W. That is, it will combine the first and the second. W would be the second argument, the second of other. Okay, so it mixes the first value of one structure and the second value of the second structure. So suppose you have a pair of I32 and str, that is 5 and hello, and then float and char, that is 3.14 and x, then it will mix them. The invocation is given here, line number 19. So we invoke mix on P1 and we pass P2 as the argument. So it will take the 5 of first and x of second, and it should print first is equal to 5 and second is equal to x. So I'm slowly introducing in more complex syntax because that's how we learn. And the examples are kept simple. So we run this and it should be Gen3. And we have first is equal to 5 and second is equal to x. So generics is a very interesting topic simply because, for example, you have seen this, okay, largest calculation. So any value which satisfies two traits, partial order and copy, then we can do this, okay. So that's all you have to implement in order for a value to run for largest, okay. So this point here is that you write one piece of logic which operates on multiple types, so you don't repeat the code, okay. Generics are very important topic either in C++ or in Java or Rust, simply because consider standard library of C++, or even for example consider the generic standard library of Rust. You see this vec, okay. We can construct a vec of integers, we can construct a vec of characters, we can construct a vec of string slices or strings or structures, okay. We can construct a vector of almost anything, any kind of object. So how does that work? You don't know all the types beforehand, that what types are going to be passed. So definitely the container vector will be such that it can handle all kind of types. So of course you need generics for this kind of behavior, okay. When you don't know in advance that what kind of types will invoke your code, and you have some sort of logic which should be repeatable, then you use makeof generics. So with this, I will end this video, and in the next video, we will see even more complex real world kind of examples, and we'll consider various different stuff which combined with generics in general. So stay tuned for the next video, and thanks a lot for watching the video. I'll see you in the next one.